A very good evening to everyone. Greetings from the team Petroleum Engineers Association. We are very pleased to introduce a week online course, Mudlogging in Well Monitoring by Mr. Chanam Singh sir. Mr. Chanam Singh sir has worked extensively in oil and gas exploration with multidisciplinary teams for more than 24 years in more than 9 countries. Currently, he is working as consulting well site geologist to Kane Oil and Gas India. His earlier experience included as field service manager, Schlumberger, Houston, USA. Prior to this, he worked as operation manager, Geoservices Malaysia. Mr. Singh had worked as mud logging geologist, data engineer, and early peak detection engineer in both onshore and offshore rigs in India, Oman, Sudan, Yemen, Russia, Indonesia, and Brunei before joining the management. Mr. Charan Singh sir also attended various technical safety and management training of geoservices and Schlumberger in Paris, Houston, Tunis, Abu Dhabi, Mumbai, Singapore, and many different places. So today the first day of our session. So let's start the course. Thank you, sir. Over to you. You can start.
Thank you, Nikhil, and the team from Petroleum Engineers Association, and a very good evening to all the participants. Uh, Nikhil, am I audible enough? Some problem with the mic today. Hello, hello, Nikhil, can you hear me? Hello,
Hello.
yeah, yeah, Nikhil, can you hear
Sir,
me?
voice is very low, sir. Yeah, I can hear you, sir. But voice is very low, sir.
Yeah, okay. I'll try to. I don't know something is wrong, but okay. If you cannot hear me, you please let me know anytime. Okay, I'll try to speak like this. I'll
Okay,
try
sir.
my best. Okay, so yeah, once again, thank you, Nikhil, and the team from Petroleum Engineers Association, and a very good evening to all the participants. As Nikhil mentioned, this is a we'll go through the some part of mud logging, which we use in well monitoring. Uh, which I hope will be able to give you some insight about the mud logging, the uses and the importance of it. To begin with, let me, this is my profile. I did my geology degree from Ferguson College, Pune, and after which I did my master's in petroleum technology from Wadia College, Pune. Then I started working in this industry from 1996. Then I have been through these geo services, and then later, acquired by Schlumberger, as you know. So currently, I'm working as a well site geologist for decane operations in India. I was also in the offshore KZ offshore part where we discovered two wells in 2018, and currently in the onshore job, which I was with Schlumberger project, and then later with this Halliburton. But then from April, the project was suspended due to this pandemic, and now we are starting again. So hoping to go back again. So this is just to give you a bit a profile about myself, and I wanted to share a little bit about the trainings I had. I attended so far. One of the main reasons is that, as we have mentioned, I'll be going through some part of as a part of mentoring or to share you how the oil and gas industry, how to enter in the oil and gas industry, and then how what is the experience like working overseas. So the main reason I wanted to share here is that once you go and you are working in a good company, like I was lucky to work with for Schlumberger for some time. So different training modules have been, we had to attend it, right from technical, to various safety, and also went through the management as well. As you see here, let me see. Let me just put it. Okay, so I started the first training in India. It was in 1995. Then I joined as a mud logger and went through various technical trainings. Then I switched over to the operations management. Then after some years, including the HSC part, and then I came back to the technical again. So after working like almost 10 years in the office through the for the office, the operations management, I came back to the technical side again. So what I want to say is that, when the situation are, what to say, I would, from my experience and from my, part, I would like to say that it is always good to stay with the technical, the management, because of, oil crisis and all. I was there, but then things didn't go very well. So it's, the guys or the people who are in the technical uh, section or a technical side, they survive. So I was also in the team that was not lucky, but then because of these various trainings, I came back to the drilling side and then to the well geology. So that helped me to, to remain. So from my experience, this is the reason why I'm saying that it is always good to stay with the technical, whatever you are there, and working in a good company like Schlumberger, you can move around from one to another, like that. And this is why one of the reasons I just wanted to share you about my trainings attended and what the big companies take care of it. Okay. Okay, now this is the very brief, the agenda that we'll be going through it. I know it's not going to be enough. It's a very short time. In that I don't know how much we'll be able to cover it, but we'll try to cover this one in this week. So in this mud logging, I'll go to the from the very basics, okay? So you don't have to worry. And I think we have a team mostly is it's about 90 to 95%, I would say, are students from petroleum and geology background, and I think few are from the industry who have already started working in mud logging, and a few other sections. So you don't have to worry. I mean, I will try to cover from the very basics. So the first one, in order to understand what is mud logging and what are the importance in well monitoring in a drill site, so we need to understand how the mud logging works. In order to understand that, we have to start with, the sensors. Okay, so this is a surface logging. It is also known as a surface logging because there is no downhole tool run in the well. So let me just repeat it. Unlike the MWD, LWD, and unlike the wireline tools, wireline jobs, so the mud logging is purely a surface logging, which means that the crew is there on the surface, all the data acquisition, all the sensors are there on the on the surface. So no equipment or no tools are done inside. So I just wanted to make it very clear. Okay, so today we'll be talking about sensors and the data acquisition, and then after that, tomorrow we'll be talking about the interpretation and the plots of these sensors. They will bring the signal from the different locations, from the different sources, and these are plotted. Okay, these are plotted as after the acquisition in the form of alphanumeric and also graphs. So I hope at the end of this 1 week course, you all will be able to understand what all the different curves, or what does the plot or the graph speak about, and what do they tell, and what are the responsibility of the mud logging crew in terms of communication, in terms of monitoring, in terms of setting alarm and communicating to the drilling supervisor, who is the company man, and before that, on the rig floor, where I mean, who is the driller. So it has got a lot of important things to do, and that we'll be covering it tomorrow. And not only that, nowadays, these days, all the data that are being recorded are transmitted to town via which through various ways. So whoever has got access, okay, whoever has got access to the well data from anywhere the globe will be able to see it in real time. Okay, so they will be able to see, let it be onshore or very remote areas offshore. Whoever got to access will be able to uh, see what's going on the well. For example, in and when I was in US. So okay, so I was a part of the team. We were sitting in the this Chevron office in Houston, and we were drilling two wells in the Gulf of Mexico. So as the job was going on, we were monitoring it. The crew was also monitoring at the rig side, on the offshore, very far offshore of in Gulf of Mexico. But we were in the Chevron office, important operations like cementing, the LOTs, the leak of tests, or the FITs, formation integration test, and any other critical operations. We could monitor it from inside the Chevron office in the very much downtown of Texas. Okay, so the drilling guys, the drilling team, the drilling manager, the drilling engineers, the geologists used to come to our monitoring room, and then they used to see it, and we used to submit the report. So those things from there, we could see it immediately, what was going on, whether the whatever test we conducted was okay, whatever we did the job was good or not, without having to wait for the next day all the reports. So these are the things. So in order to get good and the reliable data, so we have to make sure that all the sensors are properly installed and all the calibrations are done correctly. Otherwise, we will be whatever we will receive is would be a garbage. So here comes, even if you are not going to work as a mud logger, I know that most of you are undergoing this petroleum engineering courses. I mean, your degrees. But if you do not understand what these guys are, what the plots are there, or if you do not understand it very clearly, then it is not going to give you very good information, and you will be depending on somebody or to ask or to send you the report. But once you know it very thoroughly yourself, then you don't have to really wait for someone to explain you. You can see it yourself. These days, as I mentioned earlier, onshore, offshore, be anywhere, the communication is very good. You can see it yourself. So this will help you to understand uh, whether the data is coming is not good or not, or whether it is giving any kind of this alarming. So these things we will be covering it in brief. There's a limitation of time, but we'll try to cover it. I'll try to cover it as much as possible. And of course, if you have any queries, you can always ask me at the end of the session every day. Okay. Next is we'll be covering a little bit on the drilling cost optimization by using these advanced applications. Okay. And then as I mentioned, every day we'll have the Q&A. Nikhil will be coordinating it. Then so I divide into three parts. The first one is data acquisition and interpretation. Then the next 2 days, another 2 days will be on brief geology. Again, here we will not be going to the very basic geology, okay? What are the different types of rocks and how they were formed and on and so on. We do not have enough time to do that, and I'm sure you must have already studied all the theoretical part in your universities. So here I'll be talking on the practical point of view. Okay, very brief. Of course, I will be talking very brief. And uh, with regards to the well site geology, with regards to the edge site quick formation evaluation. So I will be talking and I will be sharing you some slides, some photographs, and so on from the point of well site study, practical view. Okay, practical. So again, I repeat, we do not have time, and we will not go through all the entire geology which you must have studied 3-4 years in the university and 2 years and 2 years in your master degree. We cannot cover that, and we do not need. Okay, and also those who are from the non-geology background, please do not be scared because you do not have to learn by heart everything. Even here, you do not have to learn by heart, but you just need to know the technique. Okay, you just need to know what are the properties. Like for example, when you study a sample, what are the properties that you have to describe? So I will be going through the slides later. You do not have to learn by heart like what you did in the universities. For example, how to describe a sandstone. Okay, how to describe a shell, how to describe a like that. You do not have to learn by heart. I'll show you the techniques, what are the properties. Okay, so but then just need to follow it, and then that's how you will analyze. The next part is having studied, all the samples, they analyze it, and then you have your data. Next is the mudlog and the creation of Mudlog and the composite log. So the Mudlog is nothing but it is a representative of the all the formation, all the the geology, or rather the lithology of the well drill, together with some other combined parameters, like the ROP, the rate of penetration, the gas information with some comments, what was the weight on bead there, and so on. So I will be explaining you with some example where I have worked myself, and also then I will be talking of the composite log. What is the difference between a mud log and what is a composite log? How to read it? What are the scales, the parameters? What are the importance? What does a log say? So composite is nothing but together with the addition of some like LWD or well and parameters data that the data obtained from those. So together with we combine with the geology part, and it becomes a composite log. So we will be going through it on the, I believe it's on the fourth day. Then some concept about these cavings. So I will be giving not actually a detailed well case study. So I'll be sharing some of my experiences, very recent one. So how much caving can give you trouble, and what are the sources of what are the types of cavings, and how does it look like? And we did some studies, so I'll be giving you some brief idea on that. So next time when you see a caving, you won't be scared. And the third topic will be on gas. Okay, so as you know, at the drill site, gas detection of gas is very important from the safety point of view, and then from the formation evaluation point of view. So here I'll be discussing on that part. And just to let the detection of gas, it's only the mud logging company at the drill site who is detecting about gas. Okay, so when you say gas, there are like mainly I would say there are like from safety point of view, it is the CO2, carbon dioxide, it is H2S. These two are detected with the help of sensors, and then the hydrocarbons are detected through with the gas panels, okay, gas detectors. So I'll be going through the types of the detectors, what are the factors that we have to look into it for QC, what cares are to be taken, and in what way they can help us in drilling safely and in terms of formation evaluation together with all this. So gas has got a very important, very important role in drilling a well safely, and in not only safely, then in evaluating a well. So the other topics we'll try to cover it. Of course, so it will be very brief, but I will try to cover as much as possible. And on the last day, I still keep one day in case we could not cover anything. We'll go through that. Okay. So without okay, now I hope this much introduction is good enough, and let me just go a quick video. So wherever you are, let us prepare to go to this one offshore. Okay, let me see if the link is working or not. Oh shit, I don't know why it's not working. Let me just 1 minute. Nikhil, are you able to hear me still?
Yes, sir.
Okay, yes, please listen to me.
All right, I'm going for lunch for a third time, guys. Keep going.
Sir, video is not coming, sir.
Call me if you need me.
Sorry.
Thanks, guys.
So video. Sir, I think you have to open your YouTube screen, sir.
don't know me, I'm Paul Dwyer. I'm the offshore manager. Most of you guys are regular returning, so I hope you enjoyed your time off. Let's take it one day at a time. Also, guys, let's remember out there, let's work smart and work safe. Look out for each other.
Oh, Nikhil, whatever. Okay, okay. No, I'll skip to this. Hold on. Hello, Nikhil. Yeah, can you hear me now? Hello, Nikhil. Can you hear me?
Video is not visible, sir.
Oh,
Sir, I can hear you, sir, but video is not visible.
oh, it was not visible, is it? Okay, okay. So, yeah, okay, I can share you the
No,
link.
sir. I think you have not opened your YouTube.
Uh, now can you see?
Okay, sir.
Yeah,
Okay.
now can you share me? No, I mean, can you see
Yeah,
my
now
screen?
you can start, sir. You can start, sir.
Okay, okay. I don't know, something went wrong, but I was seeing in my this one. Okay, now sorry for that. I'll share you the link. It was nothing but just to say show you some this offshore life. Now, so there are three main aspects of this mud logging. Okay, so there are main three aspects as you see here. The first one is on safety. Nikhil, can you hear me still?
Yes, sir. Yes, sir. You're
Okay,
audible, sir.
okay. Whenever you don't hear, you just let me know. Okay, I'll continue.
Okay, sir.
So there are three main aspects. On first one is on safety. I think you all heard about Macendo incident, Piper Alpha, and also recently the one in Assam. So for obvious reasons, there are sometimes incident to happen, but then of course. Sometimes it may be beyond, but there is a lot of care, care to be taken. You'll see it as we go through it. So one thing is mudlogging, the presence of mudlogging is very, very important from the safety point of view. Then the second thing is on the formation evaluation. Okay, so the formation evaluation, like we talk about it, the study of the subsurface, I mean the cuttings, to study the geology, and also about the gas depiction. This will help us to study the on the formation evaluation. And third one is on the drilling optimization. So from these parameters, from the analysis of the curves of the plots, what can be improved, and how can you optimize cost, etc. Okay, it's just to it's more of the same again. First one is monitoring for safety. Then the formation evaluation point of view, then and one thing is on the the communication. This is a very important role because as you know, the drilling supervisor, the company man is the man in charge, but he is not there all the time. He is not there all the time watching the monitors. He has a lot of other responsibilities, including logistics. He has to care for all the services, so he is not there in his office all the time. So he may not be, while drilling or critical operations, he may not be there. So somebody has to inform him, on any changes in the critical operation. And also the rig floor, who is the driller, he is not able to watch his gaze all the time. He is very busy physically, handling all that, drilling the mechanical stuff and so on. So then who is there? He may not be, and he does not know, the like the pits, a lot of drilling fluid transfer, the gains, and sometimes can be losses. So he is not able to watch his gazes all the time. But it is the mudlogging crew. It is the mudlogging crew who are there inside their cabin with all the sophisticated charts and so on, all the drilling, the alarm setting. So they are the first eye. They are the first eye, and it is their responsibility to inform the driller first of all, then the company man or the drilling supervisor, and anything to do with the subsurface geology, we have to inform the well site geologists. So so the communication is a very key in order to communicate it correctly, whatever is there. So we need a very good mud logging crew, mud logging equipment for the safety of the well. And of course, whatever is that data being recorded or being monitored. These are used for the future, wells, and also all the necessary reports to be sent to town. Okay. Now, uh, what is actually mud logging? So I'm not sure whether everyone understands it. So mud logging, we do not mean actually logging the mud. Okay, mud is nothing but the drilling fluid. Okay, that is used to drill a well for various obvious reasons. The functions of the mud, the drilling fluid, uh, you know, uh, we use mud. Okay, so why we call mud logging? Whatever data acquisition, whatever information that the mud loggers get is with a medium, using the drilling fluid, that is mud. So there are no, as I mentioned earlier, there are no tools or no sensors downhole, unlike the LWD or the wireline. In Logging is nothing but the continuous recording of data. In case of wireline, we use wireline. That is why we call it wireline logging. Okay. In case of the surface logging, which is on the surface, we use the drilling fluid. That is mud. That is why it is called mud logging. So I hope everybody is clear. Those who have not been very clear with this concept. Then study of cuttings carried to the surface by mud. So whatever depth we drill it, the cutting has to come to the surface. Okay, and it is the mud which brings out to the surface. So the geologists or the mud loggers will be examining the samples under the microscope, and it is with the help of this the cuttings are brought and it is studied in the mud logging unit. Then geological analysis, as we told about it, the same. Then gas and oil source, which we have already talked about it, the details will be coming in. And like the monitoring of drilling, this is eyes and ears, as I have just highlighted. Again, I'm repeating that it is very, very critical. And the mud logging is the company or is the division who monitors the whole process. Let it be drilling, let it be tripping, let it be cementing, or let it be any kind of wireline from the start until the end. It is the mud logging crew who are present all the time. The other service sectors, like cementing, they are there only during the cementing time. MWD and LWD guys are there, or the engineers are there only if their tool are run in that particular section. For example, if the section is of the in a particular well, if the MWD sorry, LWD is on the neck, in the next section or in the second section, they may not be there. And if it is vertical well, they may not also be coming. But the mud loggers will be there all the time. Okay, and then as I mentioned, any anomalies, any changes in the drilling parameters. For example, when we are using particular flow pump, the pressure has to be that much, for example, like that. Okay, so any changes, anything, any deviation, it has to be reported. And then compiling data on the logs, as I have mentioned about the mud log and the composite log, and also in the time log, which we'll be studying it later. And okay, now, so how does it work? Like, this is a rough sketch. Okay, so this is the inside view of a mud logging unit. In this particular unit, we had also it was a small combo unit. Combo in the sense the MWD and LWD guys were also sitting inside the same cabin. The DD or the directional driller was also there. The geologist was also there. So in fact, the cabin was a bit small, but everyone, all the team were in the same cabin. Okay, so it was a very nice place to work it because every all information exchanges was very easy. It was very easy in terms of any problem. The DD could and the geologists could talk directly to each other. The LWD guys, the screen, and anything to do with. So for working wise, exchange of information, it was very good. Uh, sorry, the left side is the logging part. These screens are there, so it has the gas panels and the other different like the different monitors is like the control room. Whatever is going down, because of the sensors, you are able to see it visually. Okay, you are able to see it graphically, and then you can set the alarms, and you can get it alarm even when you are busy. You don't have to watch the monitor all the time. You can set it for the important parameters, and then you'll get it alerted by the system, and you can just have a look. Anything, as I mentioned, anything abnormal, you can call the rig floor to the driller, and you can inform the drilling supervisor that for example, my pressure is a standpipe pressure is a shooting up, or there is a decrease in the pressure. Could be any reason. So you don't have to analyze first, but you have to, I mean, the mud doggers have to tell first, okay, I'm saying this, then investigation follows. So this is the thumb rule. The second part is here. These are the rec for the MWD guys. So it's here, and the role is like I mentioned here. All the exchange of data, giving drilling gas mud data to the uh, company representative, then to the geologist, the lithology gas oil source data. So almost to everyone. The logging crew interacts almost with everyone, like with the mud engineer also. The mud report, he will check on the from time to time what is the mud weight or the density going on, and then what are the mud properties, the mud is and any addition of the new mud, any transfer or any addition. The mud engineers and the mud loggers have a very good or need to have a very close communication, for otherwise, if there can be a false alarm. If the mud engineer is adding mud and he does not know, he is not informed, then they will think there is some influx on formation. That is there. And then the LWD MWD, as I mentioned here, in this case, it was together, so not an issue. So this is just to give you a quick picture to those who have not seen or who have not studied that. How is the monitoring of the well managed or monitored by the logging crew, and what are the team that he or she has to react? I mean, the just mingle together. All right, to communicate. This is another presentation, another slide. So these are the different sensors. So I'll be going to the different sensors later in the next slide. This is how the data acquisition takes place. Okay. So now from all these sensors, these are the different sensors located at the different locations. I'll be covering that again in the coming slides. For now, the sensors come, and this is the data acquisition. So different companies have not exactly same the different acquisition panels. Okay, so different. So all the sensors, they have a data acquisition panel. So I started with geo services, and we had this system, but then the software hardware goes on upgrading. So whatever is there, there will be one panel. Nowadays it is replaced with the computer, instead of many panels. So in my time, we started with the different panels for getting a signal called SCP, signal conditioning panel, data acquisition panel, and like that. So now it is made it much simpler in the form of a big computer, so who does all the acquisition part. So the signals coming from the sensors go to the acquisition panel. The gas panels are different, like for the total gas of the hydrocarbons, and for the chromatogram. So the data from there also goes there, And then there is some computation, like for example, the ROP. There is no sensor called ROP. So many of the beginners in industry confuse where is the ROP sensor. There is no sensor as called ROP. This is a calculated parameter. So I have got a slide on that as well. What are the calculated uh, parameters and what are the exact data reading from the sensor? So all the signals coming from the sensors go to the acquisition panel together with the gas data. It does the calculation, data storage. So there are two types. Okay, one is the time and one is versus depth. For example, when we talk about what was the gas reading at a particular depth, so this, as we drill, for example, our TD or the target depth is 2000 meter. So whatever data as we drill, the different drilling parameters like the ROP as mentioned, rate of penetration, the standpipe pressure, the flow rate, the RPM, the rotations per minute, the torque, example, and what was the volume in the active, one, two, what were the pump strokes. Those are all recorded, and then so when we create the log, we can get it. We can get it displayed, and also for any reference, we can use the data. So these are called uh, depth data, which means that whatever particular parameter was recorded at while drilling at that particular depth. Whereas time one is sometimes we may not be drilling it, we may be stopping at one particular depth, even during the depth, whatever is recorded at time. So it's a 24-hour recording. I will show you in this chart later. Whatever data is, let it be drilling or dripping or any kind of operation. So these parameters from these sensors are also recorded and they are plotted in a chart. So that is the type of data against time. This importance, this has very good significant importance in terms of efficiency, in terms of benchmarking. Like for example, in a particular rig A, some rig is drilling. Okay, let's take it for example. In the next morning, by just seeing the plot of the previous 24 hours operation in town by the drilling manager or the drilling engineer or the well engineer, he will be able to tell by just seeing in the chart in 2 minutes, oh, yesterday the driller was making a pipe connection and he took 10 minutes. He could have done it 5 minutes. Or sometimes, he could have, the guy took it 15 minutes. So when I started, like in '96, I was in one of the ONGC rigs. That time we did not have a very good or very good system of recording, and the town, like nobody was really, after that time breakdown, being, so sorry. At that time, it was not considered very critical. But today, just believe me, any small company to the big companies, everybody is watching. Everybody is watching it. So let me just tell you a joke. Like I was there in one rig in Assam, and in the report there was some problem was there. So I mean, in the official report, it was reported as work hampered due to heavy rain. There was another rig a few kilometers away, and then they were drilling it. So the next day, when both the rigs sent the report to town, like they were wondering, like, in just like 2 3 kilometers away, one rig was operating, drilling, and another rig there was this heavy rain. So those were the time. Today, nobody can do that. Nobody can see that. So uh, this has become very important. You can imagine now why it is important. And the guy is sitting, as I told you, in the early morning when he sees the report. The whole night he will go through in 5 minutes, and he will be able to tell exactly if everything was done correctly, properly, or if there was any issues. For example, there was a problem. So by checking at the plot, one can find out exactly what went wrong. So these can be analyzed. Here lies the importance. Okay. Again, from the like I mentioned, geological data from the sample analysis, the oil source, etc. Those also will be entered in the form of log, and then we will create a log. Okay. Then from the LWD, if there are any logs run or the MWD surveys, that also the logging crew takes it and then put it together. And like I saw in the other previous slide, the crew monitors it to the screen and inside the logging unit, and then the same thing is being transmitted to town via which ML, and whoever has got access to that, they can see it and monitor it from any part of the globe. So I hope this is the data flow. I hope you have a very brief idea by now how it works, what are the importance, and how the actual acquisition takes place. So we do not need to know all the different, the cards, how it. So it is just to give you how, in a nutshell, how it works. Okay. Let me see if I can share this one. Uh, Let me see. I have this video I took myself, 2005. Let me, Nikhil, just bear me. Uh,
Yes, sir, you can
Nikhil,
start, sir.
this is Nikhil. Can you see
Yes,
my
sir.
screen? Can you see?
Yes, I guess. Yes, sir. Yes, sir.
Okay, I don't know about the sound, but this is from a very old one. Okay, it's 15 years ago. I was working in Indonesia. Okay, this I recorded myself, and it's just for a training purpose or for my own sharing. I cannot share it officially. I just wanted to give you, instead of somebody is talking behind. I don't know who's that. Uh, okay, so this one I just wanted to share you an inside view. How does a mud logging cabin look like? And instead of just showing in slides. So today, this morning, I found this my old video, so I thought it is worth to share it. Okay, so it is not a very good quality. It's 15 years ago, but it will give you some brief idea, and you can see you can imagine, you can see the big CRT monitors of that time. And we use different old panels, like I told you. You can see it there. It will be explained there. Nowadays, it's a much more advanced system in almost all the companies. Okay, so just go through it. Bear with me with the quality and the sound. Okay, I'll just run the video. This is the Geo Services logging unit with LS2. Here is the crew. Please introduce yourself. My name is Jeff. I'm from Indonesia. Hi guys, good evening. This is Rana from India. So here we are in our unit to tell you something about how we work over here to give you a brief idea. So as you can see, this is one of our store sections. So it is mainly the equipment which you are going to use. And like for this example, this is the sieving thing which you use for sampling, and this is the trays where we take the samples to give it to the geologist. Then come a little refreshment kit with coffee and teapots and everything, with some of the innovative ideas like drinking HQ. You can have a look at that. Then just if you turn towards the below part, this is for the sample preparation part, that is for the drying thing. This is the oven. You keep the sample inside, you put the temperature on, which is now turned off because it's not required at the moment. So then we put the things inside and it gets dried. You come to the topper part. This is for the drill cutting samples. We take in this envelope, and this goes to the client which we are working for at the moment, which is ConocoPhillips right now. So we come to the microscope section. Here we take the samples in the trays, and then we try to look what is inside that, and there is some things to give our ideas regarding the grain size and the other things. We don't go into the much details because we don't know ourselves. So we take a look from there. Then it comes to the main part, that is for the oil which we are searching every day and night. We see for the curtain fluorescence through this fluoroscope which has the UV light inside. And this is our hardware section in a way, or the store section for the hardware part, where you can see all the things. Then I will show you regarding the name. Yeah. Sorry, now comes to our communication part. Yeah, tell me. That is voice communication part. That consists of the two of the things. One is for the read part, where you can communicate through this telephone for the paging, and there are several channels through which you can communicate to any person on the rig. Okay. And this is for the outside communication, where you can call your home, call your base office, and anything else. Then I will close it. Something is wrong. Then comes the visual communication part in a way. Here it is. Hello, Nikhil. Can you hear me?
Yes, sir. Yes, sir.
I don't know what's wrong. I was playing the video. I can see it from my screen. Uh, but it seems you cannot. Okay, okay, we'll leave it. I don't know what's wrong. Or maybe if I get time tomorrow, okay, I'll check later after this session, and then I'll
Sure,
check
sir,
what.
sure, sir.
Okay, something is wrong. I don't know why. Uh, what's it? Where did I go? Okay, okay, yeah, yeah. Now, are you able to see my screen now?
Yes, sir, yes, sir.
Okay, okay. All right. So now I don't know something wrong with the video. I cannot. No problem. So now we will be we will be going through the sensors part. Okay. So what we have done seen so far is we know that there are sensors installed. The acquisition takes place, and now I will go through briefly where are the sensors installed and what type of sensors. Okay. So this is the key part for the today. So now you know roughly what mallogging does, why it is important, and what are the different the task and with whom the malloggers communicated, and now we'll be seeing the different locations of the sensors, what type of sensors there, and after that, yeah. So this is let us see. This is a layout of a rig. Okay, here is the generator. This is the rig floor. Okay, so this part is the rig floor. These are the pumps. So the mud have got sensors in the different pits, okay, which depending on the contract, but in most cases there will be sensors to monitor the pit level. How do they do it? These are tanks, okay. So these whatever be the sensor, they will measure in order to before that, in order to measure the volume, by definition or of the volume is into L, length into breadth into height. So when a volume changes in a tank, any particular rectangular tank or in the cylindrical, it is the level or the height which changes. This the length and breadth will remain the same. So these different senses, they will be measuring uh, the height, or in other words, the level of the fluid. That is how the principle works. So what happened is, it is important to understand or to know what exact volume is in the system, and how much is pumped, and in the mixing pits or in the reserve pit as well, what are the volumes. It is very important. uh, then when they mix also, like when the mud engineer wants to mix, or wants to transfer anything, so this gives a very good information. And sometimes the tanks are interconnected, and if there is any leakage from one to another, it is the mud loggers who will be catching this. It's very important. It's very important. Okay, so it is the mud loggers who will be catching this. How? Uh, because, for example, this is connected and there's a valve. Somehow, by mistake, somebody went there and opened it, or by some for whatever reason or something, the valve is broken. Nobody will be there, when in the idle area. But these smart loggers, with the help of the sensors, they will be able to monitor it. So these are the pit level sensors. One at the slug pit, one at the mixing pit. A mixing pit can be more slug. I mean, depending, and active system. Okay, this is the active. So in some, depending offshore, onshore, the number of tanks may be. Sometimes there are many, so there can be many. In some cases, there are more than a sensor, more than one in one tank. So we can make equalization. It depends on the contract again to have more accuracy. Okay, that's the active pit. Okay, then there is all the pits basically, whatever is possible. This is to measure the volume. Pump. Sometimes there, in most cases, there are minimum 3 pumps. So two may be running at a time, and one is kept as a spare. So I do not see two, rig with 2 pumps these days. These 3 pumps are there, and so the stroke counters are installed. Okay, so stroke counters are installed. They are of different types. I'll be coming through it individually after this. And then in the standpipe, okay, so whatever mud is being pumped with the help of this pump from the active system, okay, from the active system, uh, the pressure has to be monitored. which is called standby pressure. Okay, so I'll be showing you the picture of the individual sensor also. How does it look like? Okay, and what kind of sensor are there? So it's very important to install a sensor there. And then coming to the for the any kind of hook movement, there is a sensor called drawback sensor. So it will tell the position of the hook. From there, the ROP, for example, the hook speed, these are all calculated values, we can get it. So when we say ROP, the rate of penetration, how fast the rig is drilling any particular formation. So this is how can we get it? We get it with the help of the drawback sensor. It has two proximity switches, which I will be showing it, in another slide, maybe in the next very slide. So there, the drawback sensor is installed there, with the help of which we can see only all the hook movement. And then if it is moving fast, it will the acquisition panel will do the calculation. All the computation part will be done, and it will tell you what is the hook speed. It's very important while tripping, and while drilling. For example, like I mentioned you, from the charts that I mentioned, the guys in town, the company, like the drilling manager, the well engineer, or to the client, or whoever is seeing there, is they will be able to see it if the driller is moving very slowly. So with the help of this sensor only, they will come to know. Oh, this was supposed to be. They could have easily run while running in the casing. They could have easily run this many joints in per hour. But why they're running slow? How do they know? It is from this sensor. Okay, so it is very very important. And without this sensor, you cannot get the rate of penetration and many other. You cannot know, the, the the depth and so on. So it's a very important while drilling also, or any kind of operation. Without the depth, it's very, it's very very, in the very earlier days, without these sensors, they used to do it kelly marking, call it kelly marking. But nowadays there nobody's doing that. It was a purely manual. You can imagine the pain when the RPM sensor was not working. They had to do it manually, so they could check it from time to time, but in between, if there are changes, minor changes, nobody knows what was the actual. So in terms of data quality, it was very very poor. Nowadays, because of this mudlogging, the increase in the in acquisition and the system, that's making life easier. For the RPM is for the, this rotary tables. If it is top drive, it is put in the top drive, and sometimes it can put here also. Then yeah, we talk about it. Then the flow line. Okay, in the flow line is the return sensor, which will tell you at what flow rate, the mud is coming out. So important thing is it may not be very accurate, but the important thing is the relative changes. Okay, so that is very 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 important. Then the trip tank. What is trip tank? While tripping in or out, while tripping in or out, this trip tank is used. Why? Because this is a smaller volume, the accuracy will be more. If you use the whole system, if there is a gain of zero point 0.5 barrel, or if there is a loss, it is very difficult, because so many tanks are there. So the whole reason of using a trip tank is that while tripping, mostly while tripping, or while is on like, flow check. For example, if there is the flow check means that the driller does it to check whether there is any decrease or increase in the level. So what they do is run a uh, closed system. For example, it's running with a very closed system, and then the hole, always the hole is filled with mud. Okay, so then they will see if there is any increase or decrease when they suspect anything, or when we there are some procedures to be done. So in that case, they use the trip tank. That is the whole purpose of trip tank. This is all same as mud tank, but it's a smaller one. And then for a closed system, you can have a closed system. Okay. And for then the cementing unit, sometimes there are sensors, pressure sensor, and even for the, like a stroke counter, also it can be installed to know when the cementing job takes place. Then well control, wellhead pressure, and shock manifold, the sensors also, well, the kill line, it can be installed. This is also pressure sensor. So in a nutshell, and this is a mudlogging unit. So the guys will be running, so if it's onshore or offshore, depending on in the lane rigs. In onshore, it is close to the cell checker area. Why? Because all the sample cutting, you see from here, the flow line comes, it goes to cell checker, then all the cuttings are dropped here. So some tray will be put here, the sample plate. That is where the sample catcher collects it. The rest of the mud will be filtered and going back to the system again. So normally the mud logging unit is placed very close to the cell shaker area. And in offshore, sometimes it is just above the cell shaker in another deck, another floor. Okay, so that is all. That is very important. And what else? I think yeah, you have a quick idea. Where are the sensors? What types of sensors are there? Okay, it's another separate meter diagram. Okay, now I think I will go to the individual sensors. We have around 55 minutes gone. I think I should be able to cover it. So, uh, there are, see, this we studied in the old system, and I think it is still the same. Let me tell you the sensor types. Okay, there are three main types. I don't know if in all company they follow the same, but the principle should be the same. Fast data, monologue data, and pulse data. Okay, so fast data means like the signals comes 10 times in a second, like 1/10 of a second. So it means this is very fast. Okay, it takes only 1/10 of a second. So that means in 1 second it comes the 10 signals, right? So these are the very important parameters like torque. They just come and go, like the weight on hook, then the gas, total gas, then semantic unit pressure. So these are considered as fast data. Monologue is sample per once per second. Okay, this medium kind. And pulse is like as I mentioned you, there are like in the form of pulses. It means whenever it touches. For example, when we use in the RPM the rotation per minute, so only if it rotates. So what we do is what they do is this is the sensing part. Okay, this is sensing part. This is a sensor actually. So it's a cable there. It's a two-wire. This junction box. It goes from here. It goes to the unit. Okay. So if a metal part comes here, it is applicable to the RPM and to the pump strokes and any kind of pulse sensor. So it signal. It detects. For example, there's a metal. In the pipe there is a kind of nut bolt is placed there. So whenever it rotates, whenever it comes to this place, it will detect and it will glow the LED. That's how it picks up one signal. In case of pump, I think I have more slides there. So in case of pump again, the same thing will this happen. Okay, I mean it will be detected. So it is in the form of pulses. All right. So now this is the torque sensor or the Hall effect. This is an old type of sonic pit level sensors. Some companies are still using it. Some companies have used it in a better one, better type. But this was a very common one. So this is a sonic. It sends ultrasonic waves and it detects the level. So it tells what is the height present level, and then the computer does the calculation for and gives you in terms of the volume in barrels or cubic meter, etc. So fast data, monologue data, pulse data, these are the sensor type. Okay, quickly. Some sensors, I think I have a bigger one, but I'll just try to cover quick. This is the same one that you saw for the pulse. This is the old type of, the pressure sensors. These are hydraulic type, but we have another new type. Okay, so I have that one. We used to use all type. This is for the drawworks or for the hook movement. I have got another one. This is the again the same pulse type sensor we use for RPM, or there are two types. One is round and one is the rectangular. This is the same thing. Okay, this is for the conductive resistivity or conductivity. Uh, this is for okay for water-based mud, but not for the oil-based mud. I don't see any more these days, except very not that really useful. But we used to put it as part of the contract. And this is for the weight on hook. This is the tensiometer. There are two types. Okay, this one in the drill line, placed in the drill line, and this one in the Martin Decker. So this used for weight on hook, but there are two types. This is the hydraulic type. This is for the Hall effect, which is to measure the this torque. Okay, it measures current actually. Okay, now the proximity. This is for the on the rig floor. One thing I think I forgot to mention. So normally the sensors. So the mud logging companies earlier we used to run individual cables from the mud logging unit to each sensor. Then with technology or with advancement, then we use multi-core. Okay, so that time when we are using multi-core, we used to say that one goes to the rig floor. I mean, it's not necessarily on the rig floor, but the sensors nearby the which is connected. So we use only one junction box. Okay, one at the cell seeker area and one at the pits or pit room. So it is just to make it easy. That's why the name rig floor is there. All the sensors located on the rig floor will be named as that. The first one is the drawwork sensor. As I mentioned, it measures the hook height. What does it do? It measures the hook height, and it has two pulses here. I mean, two pulse sensors. It's a proximity. It's a very small one. So this is moving freely. Whenever it moves up or down, clockwise, anti-clockwise, it will understand. That's how the hook uh, movement is monitored, okay, and also recorded. So do not think too deep. It is just to give you exam, and you are not going to work. If you're going to work as a mud logger, you will be studying this. It is just to give you the technical specs. What are sensors? What are their properties? How does it work? You don't have to remember. I'm just giving you. I'm just sharing it. So our main course will be our main top interest will be on the interpretation part, okay, the monitoring part. But in order to understand that, it is good to know how do they work. That is why I'm trying to share it. So don't take it too complicated, and you don't have to remember everything, okay. So I'm just giving you this idea. So by spending another half an hour or another, by spending today like an hour, it will help to you to remember. And once you have this concept, you can make it always clear yourself. Or when you work, when you go back to the rig, or when you join industry, or when you go back. And this is just to give you an idea on how the sensors, what are the different types of sensors, where are they located, and then how do they give signal, and then from there we use the plots and how we interpret. So that is why, just to give you some idea, okay. So this is about it. And RPM, I have already explained it. This is rotations per minute, okay. Then nowadays the logging company even do not have it, do not need to install it. Torque and RPM comes as a part of package. It's a nice package from the drilling, from the top drive. Top drive normally gives it, so you just tap the signal. It's not taking, one thing is there is some confusion. It is not tapping the value, it's tapping the signal. And you have to calibrate it yourself and make sure it is same with the with the rig floor, okay. So sensors can be installed, but it's not very safe, and sometimes it can give I mean, you need to, during the critical time, the same, it can just snatch away. So the best thing is to get it from top drive, okay, which is normally the standard case now. I have not seen installing by the mud logging companies individually. Okay, so these are all very important, very important sensors. The wear on hook. If this not working, nothing will work. If this work doesn't work, then you don't get anything. And you can imagine, if the drawwork sensor is not working, how will the driller know what depth, or the company may know what depth? Okay, they have to monitor this. So these are very critical. That is why it is very critical. There are two types, like hydraulic type. No, yes. Then also tensiometer. There are two types, all types. So now it's Rosman, good ones are coming. Then we continue still with the rig floor. Why we call it? Because these positions are located, and I will not go through all, but I will try to pick up the important ones. Standpipe, as we all know, why we need it. When we are pumping it, when we are pumping with particular flow rate, the corresponding pressure has to be monitored. For example, we are pumping at 1000 GPM, 1000 GPM, the corresponding pressure is like, it has to be like, depending on the depth, depending on the annulus, there are so many factors. But let's say that it was like 1500 psi. So the sensor, if the sensor is a faulty, you will not know whether when it drops or leaking or so. So you will not know if there is any well issues, you know hole collapsing, or that. So that is why it is very important to have this correct reading, and it has to be calibrated very, that's very important. So most of the companies come with the sensors come with the manufacturer's unit, and most of these sensors are now 4 to 20 milliamps, okay. These are all types. The new ones are coming like 4 to 20 milliamps. I think most of the companies are using that, including the drilling crew, if I'm not mistaken. So it's very easy. The manufacturer's calibration is coming there, but you need to cross check it. The loggers have to check it. The company man has to see it himself to satisfy, and the geologist also has to make sure everything is correct. Once it is calibrated, make sure that with the rig floor is the same, then you can rely it. Then all the plots, all the charts will have is valid. The value will be useful. So it is very important to make sure that in the start of the operation, the mud loggers calibration is correct for all the sensors, including the gas panels, then you can have a safe and very reliable. Once you have it, the plots will have a meaningful, chart. So wellhead, this is actually not the edge to edge. It can be on the rig floor. It can be also below, but as closest to the bell nipple. So edge to edge, I will be covering it in the gas section. Okay. So always there is one mandatory edge to edge sensor. One is inside the unit, and depending on the contract, different locations. All right. So we can do the rig floor. This is some of the offshore. We will not go through it all. And important thing is, we are not talking only about the sensors. As I told you, there are some parameters are calculated ones. For example, this uh, wait on sleep, this wear on beat. Okay, there is no sensor as wear on beat. Okay, there is one sensor, so it's a calculated one. Okay, there is no penetration is a calculated one. Okay, for example, on this wear on beat, so total string off bottom, we call it off bottom. When it was when we, suppose we are drilling at 1,000 meter, the driller lifts it up, okay, just few meter above, and let's say the total weight is 100. Okay, that is the total string weight. It is 100. When you start drilling, that 100 drops down to 90. So what the system calculate is whatever is the, from that last one, it is taken as weight on beat. So in other words, when the string was total weight was 100 kilopounds, and now it is 90, then your weight on beat parameter will be showing 10. How is it? It is only one sensor. There is no two sensor. Okay, it is a calculated one. The system understands it, and it is calculated, and it is giving. So it is called calculated value. The rate of penetration. Okay, so the hook height is recorded by the sensor. So and then it will record time as well. So if there is changing with drilling, or while tripping means movement, it will calculate how much distance has traveled in particular time, and it will tell you the ROP, the rate of penetration. So just to repeat again, to all the beginners, to all the students, there is no separate sensor as called ROP. I heard the new Mudloggers used to say, where is ROP sensor, which is completely wrong. There is no sensor called ROP. Okay, it's a calculator. Then similarly, like stand counts, when we are tripping it, sometimes what is a stand? It's a one drill pipe single. In most cases, there are three single pipes. Okay, the three singles, and join together and call a stand. In some place in small rigs, it's two. So those calculation in the system, they put it like, one stand make like this much, let's say one single is like 9.5 or 9.8, let's say 9.5, then like a little more than that, little less than 2, they'll put it, so it will understand. Will not go to all the details. So that is how the system, you have to tell the system to understand that the movement from the on sleeve, off sleeve uh, is one stand. So it will tell you, and the numbers will be written like stand 1, 2, 3, like that. So during the operation, the company man or somebody will ask, how many stands have we have pulled out? It is from this system that we'll be able to know it. Similarly, all these are hook height is also like from the position we know the uh, calculated the pump strokes. Okay, how many strokes per minute, we call it SPM. Okay, so these are all calculated. RPM is the same thing. Drawworks, I think we have covered it. I'm not going to the details. In the drawworks, this is the place we call it rotor cell. This is the sensor. Okay, if you have to install on the rotary table, this is where. But then nowadays it's all in the top drive. Okay, so you don't have to really worry it. You get it. These are still the declaw sensors. As I told you, these are all type of the wear on hook, or these hydraulic pressure sensors, and this one is the that yes, this is the deadline anchor. Okay, so here where the tension is there, it's measuring the tension actually. So then that is converted to weight. Okay, and then yes, this is the electrical one. So here nowadays most companies are using this. The MWD guys also use this kind of thing, and the Mudloggers also use this kind of sensor. Okay, so the tension, this is that one was a hydraulic one as you saw there. So this is the hydraulic one. Okay, then this is the electrical one. It's like a tensometer, or call it tensometer, but this measures the weight, the total weight, depending on the tension of the cable. Okay, And see, these are the pressure sensors. These are all type, I would say all type. So here, okay, just to let you know. And this is again a well air pressure is the same thing. This is another type, so you get another new type these days. So I don't know, it's a different company would have a different, it changes. But this is about this is the Rosemount. I have seen this is all of the little bit recent one. Okay, so again these are all pressure sensors, 50 bar. Same thing again. This is the torque sensor, okay, which measures the current actually in the motor. So is another very important. This is very pretty much standard. I have seen only this type in most of the companies. So this is the torque sensor, okay. Then like I have already mentioned about the pit sensors. This is a shaker area. We call it shaker. It's not necessarily at the shaker, but the pits there. Trip tank, which I have already explained. This is a very old type. Okay, these are all types. Float sensor. We had this float type that time with the potentiometer. This is very old type. Then the sonic. Then the Vega sensors. There are very various versions. These are very old type, and sometimes the used to get stuck with the basically a floating device or floating some part was floating on the mud. So then with the help of a pulley, I worked that in that type also. So sometimes it gets stuck there. So it's not very reliable one, very old type. Now you don't see anymore. Then sonic is ultrasonic. You have seen the picture. Then Vega, various type of Vega guided radar and so on are there. Just to give you mud weight, yeah, it's not very reliable. The reliable one is DSM 700, and this is not very reliable. These types are not really reliable. This DSM 700 is good one. We're still working very good. It gives the density as well as the temperature. So mud weight out means the density out at the shaker, okay. Then temperature, we also have temperature sensor, which is very good. Normally it works all the time perfect. Then resistivity, not many people use it nowadays, and especially in oil base, it doesn't have any meaning. So H2S is for the safety. This is a sensor, okay. So these are installed at the cell shaker area, hence it's called and comes under shaker. Degasser for the gas trap, which I will be coming in the gas part. This is not the sensor, but the gas trap. All right. Then mud flow pedal, which you have seen it there. Uh, this is for the flow. Like normally we use in terms of percentage. It may not be very accurate because it works with the help of a spring. Actually, there's a flow pedal. When there's no flow, it comes. It is there is no flow means the mud loggers will calibrate it as a 0, and then with a particular with the full they'll bring it to the flow line, and then like it may be 100%. So with the normal it may be around 30-40 this percent. So whenever there is a kick or something, or losses, then it is just giving you an idea on the relative percentage. Not very accurate, but still it is working good. It's good. And some companies use like a pit level sensor as well. That also works okay, but this is a traditional one, the pedal one. Yeah, exactly. This is the one. Okay, this is a picture. So this is placed in the flow line, and there is a spring inside. So when the flow moves here, this goes there. So this one is considered as no flow. When there is a flow of like this, this is better one. This is a flow line, and there is no flow. It will be like this. But because of the flow, there's a spring there. It will move there. So this is like 0, and this one could be around 40% or 50%, because the full movement, it may not be here. It will be considered as a flow line is full, and then 100%. So this is just a picture of that. It's still good. It is still working. This is about the mud weight. It's very old type. The two diaphragms are there. It's making the density. So not very reliable one. So it's just to let you know how does it look like. Okay, resistivity, as I told you, some companies still use it, but it works in the water-based mud, but uh, not very reliable. And nowadays we have this resistivity in LW, so nobody really cares actually. Nobody uses it. Temperature one is still very good. It works. I have seen in all the temperature sensors working very good. But then for the out, some maintenance has to be done. Sometimes the cuttings can cover it, and then it can give false temperature. So the mud loggers need to clean it from time to time. Okay. Pits, the same thing I have already mentioned, is just a matter of in and out, so we'll not go through all the details. It's the same sensor for the pit level. The same thing. The pump sensor, we have talked about it, is the same thing. Yes, this is the old type of the prop. Still, some companies are still using it, the sonic type. How we install is, for example, this is the pit, okay? So here, such plates are there, base plates are there installed here. Whenever the volume increase or decrease, it detects. So how do they calibrate it? This is also 4 to 20 milliamps sensor. So during calibration time, they put something considering the faults, detect the signal, and then when the before the start operation, when it's empty, detect another ring. So that's empty, this is full, okay? Nothing to go very detail. Proximity, like I was talking about the pump sensor, you can install it here. Two types. Okay, movable means you can adjust it. Yeah, fixed type from the side is the best. If you can have it, is the best. Up means whenever there is a maintenance, the mechanic has to remove it and install it. So some problems are there. The best thing is plan properly before the start operation, and then have a permanent one. That is the best. Okay, so another pressure sensor. I don't think it will work this video again. So I think I will have a look, and then that's all from my side for today. And Nikhil, over to you, and for the for the Q&A round. I hope you were able to listen carefully. So today we quickly cover the sensor part and little bit on the acquisition. Tomorrow is on the plots and the graphics. So uh, Nikhil, over to you for the questions. Hello, Nikhil, are you there?
Yes, sir, I am here, sir.
I do not know how
So
how
thank you
was
so
the
much,
sound,
participant,
because
for the today's session.
hello, Nikhil, I cannot hear you. Hello.
Yes, sir.
Yeah, yeah, yes. Now I can hear you.
Hello.
Yes, yes. Now I can hear you. Can you hear me? Hello. Hello, Nikhil. Can you hear me now?
Hello. Yes, sir. Yes, sir. I
Yeah,
can
yeah.
hear you.
Okay, okay. Yes, please go ahead.
So thank you so much, participant, for the today's session. Let's continue with the Q&A session. So you can type your question on the chat box. And you will get the recorded videos, PDF, PPTs by today night. So don't worry about that.
Uh, uh, Nikhil, I saw some question here. Can you hear me? I can read it there. Yeah, there is a question from Mr. Suvam. He wrote, can we detect kick in well by checking the change in volume from the trip tank? What is the capacity of the trip tank? Okay, so just to clear, trip tank is used only during tripping or the when we are not drilling. When we are drilling, we use the hello. Hello, Nikhil. Hello. Yeah. Can you hear me? Hello.
Hello, yes, sir. We can hear you.
Something went wrong. Okay. So can you hear me?
Yes, sir.
Hello.
Yes, sir.
Yeah. Yeah. Okay. Okay. So I pick up the first question. That is, can we detect kick in the well by the change in the from the trip tank. What is the capacity of trip tank? Hello?
Yes, sir.
Ah,
The second question is,
No, 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 no. Actually, I haven't answered yet. So,
uh,
okay, during drilling, we use the normal pits. So we can aid from there. From the trip tank is used during tripping. So yes, we can pick up the trip tank from the trip tank level. The capacity it can vary. I think from 50 barrel to it, depending on the capacity of the rig of the trip tank. Yes, but this is during use during trip tank, and that is how we pick up. But kick means while drilling, so I assume from the pits. Okay. Then next question I see is, does density of a mud affect performance of the logging tool? I would not. No, I would say no, because no, tool will go it. So it unless there is influx and so on, but it's not directly. Okay, next one I see, what is the function of flow check and how many times we check it? It's a very good question. So the function of flow check is that during tripping or any other operation, sometimes we need to know how is the well balanced. So as a procedure to make sure that the well is well balanced, the driller has to do it. Sometimes there may be a very slow, losses or gain. By checking it, like normally it is like for 10 minutes, okay? So depending on that, or 10-15 minutes, it is just to make sure that it is done, the oil is not flowing or losses, it is done it. How many times? So it is uh, sometimes not necessary many times, but like during tripping out, at least while pulling out, before the pulling out, there has to be one, and in between, if there is any suspect from the monitoring by the mud loggers, it will be done a flow check if there is any suspect. And by default, when we are just inside the shoe, before going to the surface, then one more is, this is the usual practice. And another one is how we calibrate the mud logging sensors prior to start of any calibration. Is there any way to check for faulty sensors? Yes, way the calibration is done uh, by installing that. For example, no, let us say it depends on the parameter, I mean on the sensor. Okay, for the wet on hook, for example, for the wet on hook, like only the top drive, let us say the actual physical weight is around 50 tons, or sorry, 50 kilopounds or so. So that signal he will check with the driller, and then that value has to be confirmed. So that is how. And for the draw works, it's very important. So again, he calibrated, counts number of lines, and then check with the actual position. Then yes, there is one question from Mr. Pavan Patil. We have some clients says that they don't have torque and RPM sensors. As you said, they don't have actual sensors but calculated parameters. Can we ask them to have the RPM to stream calculated torque and RPM? It's a common question. So what you need to do is your company and that company need to discuss it before the start of the project, because it is not a very easy to install. Okay, so there is always this is not a common this is not a not this is a common one, but it can be rectified. Yes, you can stream the value, but then it will be through the widths. Okay, through the widths, but it is a very complex one. The best thing is the ET, or the electronics guy, he should be able to transfer, give you the point, not necessarily the sensor. That's what I told you, that you can get this signal from them, and then you can take it into your unit. Importance of mud logger. You have heard all these parameters. So if the mud logger is not taking care of the sensors, if it is not calibrated properly, if it is not maintained properly, your data will be all garbage, and your well will not be safe. Okay, then do Mudlogger only work in the rig, or some of them would work in the ace quarter or laboratory on land? Okay, this is from Varsini Gansin. When we say Mudlogger, these are the guys who work at the rig site. Then uh, So some companies have different names, like trainee sample catcher, the mudlogger, and then the data engineers, but they all work at the rig side. Okay, and then some of them are working in the office, in the client office. They are using a different name in the real operation center, like some remote operation center. But uh, what we are talking here is about the using of the data and the parameters and the plots. So they may not be called a mudlogger, but we'll be still using this streaming data. Okay, so that I hope that questions that answers the question. And yes, Rohan Gupta. So what are the reading that we get from the sensor near the deadline anchor? This one is for the wet on hook sensor, which I have mentioned. This is for the wet on hook sensor. Either you can use the electrical type one or the hydraulic one, depending on that. So the wet on hook is coming actually from there. Oh, okay. Now there is one question from Ken Anthony. Can you repeat how do we measure depth? This is from the Drovok sensor that I told you. So in the rotosil, this Drovok sensor is installed there, and it has got two proximity switches. So that will count the positive or the clockwise and anti-clockwise movement. So these are the actual sensors, and then the system will take care of that. Okay. I think that's all. Any other questions, Nikhil or anybody from the students?
I think no more questions, sir.
Sorry, very sorry for for this. I don't know what happened to the communication. Just few days ago, I was in a conference and there was no issue at all. So I will check it, troubleshoot tonight. I don't know what is wrong.
Yes, sir, we'll check, sir. Not an
Yeah,
issue,
yeah.
sir.
So I hope tomorrow should be better. There are a few questions coming up. Uh,
Yes, sir.
from one Muhammad Asim, during drilling is going on what is the role of cementing unit? Please describe. Okay, so uh, during drilling time, the role of cementing, actually there's no cementing job, but after the drilling is over, we will be pulling out and then we'll be running the casing. Okay, during the casing, we'll be running the casing. So it is very important for the cementing crew to check their equipment. Not They do not have any role in the downhole, but normally the cementing crew will come. They will check the cementing truck. They will check with the company man, with the mudlogger, and on the whole, like and then start preparing the start preparing for the job. So they cannot just sleep or eat idle. So for them there's no role, but the preparation is their job. Okay. What else? Yeah, so feel free to, if you have any questions, feel free to, Nikhil has my email, drop me, and you can still continue this tomorrow. We can still continue it if you have any more questions. Okay.
Sure, sir. So, thank you so much, Parson, for joining us with the day one. So, we'll meet tomorrow, same time, 6 p.m. And you will get the recorded videos soon. We'll post on our website. Thank you so much, sir, for joining with us day one.
All right. Okay, then thank you. I'll see you tomorrow.
See you, sir. Take care.
Bye bye.
Bye, sir.